In this presentation, I'm going to be talking about how do we write a simple C++ code that will have input read from a file, and we can also write to a file. So first of all, you will probably have to start a simple project. So we go ahead and start a project. Make sure that you do control your folder structure. Okay, so we're gonna create a Visual C++ Windows 32 console application. Now I would suggest that you put the contents into a particular folder, and if you are taking multiple computer science classes, you probably want to also mention your course. So let's say it's going to be 1436. Okay, and in this location we're going to be creating a project. So let's just create hello file. Okay, we go next, we make sure we're going to create an empty project, and we say finish. Okay, so now we have a project. So the project is stored in C Computer Science COSC 1436 hello file, and then we have the project name. So we have a project. You can also see that there's a hello file and hello file, right? So now we need to add a new item. So we need to create a source file. Again, you want to make sure and keep track of where you are actually storing your files and what you're naming files. So try to name your source files by, let's say, assignment number. So if this would be assignment 4, and within assignment 4 this would be my first problem, then you could say assignment 4 underscore, let's say, problem number 6. Okay, so make sure that you do not use any spaces in any folder naming standard or in folder naming, and no spaces at all in your source files. Okay, if you need to have something that looks like a space, make sure that you use an underscore, so there is no space anywhere. So now we're going to add this source file to our project. Okay, so we have the assignment, okay, and then we have the full path. So we know exactly where the file is. Okay, so at this point we can start writing our code. So we start by writing our header file. So you can say name, okay, and we can also say class 14368001, okay, and we can do version 1.0.0. Okay, we can put in the date 0101, let's say 2027, and then we can say project or description. We are going to learn how to read from and write to files. So now we have a header. So we start with the preprocessors, include IO stream, and then we're gonna be using namespace called std. This is going to allow us not to use std : when using CIN and cout. And the CIN and cout, and also the end of the line, mainly what we're going to be using out of the library called IOStream. Okay, so if you want to, you can also right click on the actual library and you can go directly to the library itself. And here is where you can see where CIN and cout is actually defined. Okay, and that is the reason why we need to include the IOStream. So we have the namespace. Now we can start our function. The function that all C++ code needs is the main function, and we need to return a value from that. Okay, so at this point we can just I would suggest that you start by writing a simple read in and read out from standard input and read out or print out the standard output type of a program. Okay, so let's do something like int value, and we're gonna print out an output, and we're gonna call that please enter a value. Okay, so I don't put the end of the line, so when we print this onto the screen, we're gonna see the cursor blinking after the please enter a value. At this point, we're gonna be reading into a variable called value, and after we read the value, we're gonna thank the user to enter the proper value. Thank you for entering what? Whatever is in the value. Okay, so we need the cout. Okay, so at this point we have a complete program. So let's go ahead and run the program and see if we can monitor our identifier or variable. So as soon as we are going to read into the value, we can see if the value was properly stored. So here we are declare a variable where the variable is a named memory location. So it is reserving a space in order to hold the values. Now this is an integer, so integer gonna take 4 bytes. So the system will reserve 4 bytes in memory to hold the value, and as soon as the user types in the value, that is when we actually gonna give meaning to that value by initializing it. Okay, so let's see what it looks like. So when we run this code, okay, make sure that you keep your eye on the debugger and keep track of the variables. So as you can see, here's our garbage value for our variable value. Because we're not there yet, we are not at the point to read anything into that value, so we only declared it. So the program is paused at this point. So we can continue on. And now we are asked to enter a value, and the cursor is blinking after the colon because we did not put in a new line to take the cursor down after the sentence. So here I should not type in 154, press enter, that continues the program itself, and now you can see when we look at the variables that the value has a value assigned to it, which is 154, and our program displays thank you for entering 154. Thank you for entering is a string, and the value is a variable. So if we were to rerun this program, if we relaunch it, continue on. So now we're gonna say 350. The value now is 350. So the variable holds variable values of a particular type, in this case the integer data type. So we know it works, so we can ask for a value, and we can read a value, and then we can display that value. So how do we turn this into a program where we can read it from a file and then place the output to a file? Okay, so we have a recipe, right? So we need to make sure that we can actually handle file input and output. In order to do that, we need a library called fstream in order for us to have the if stream and of stream data types available to our program. Okay, so that was our first step. Step number 1, have the library included in your program. Then we need to declare variables. So in this case, we can declare a variable called if stream is the data type. So I gotta say input or infile, and we can have another one of stream for outfile. So the second step in order to read or process information from files is to create a data type of if stream and of stream, either one, which one you need, or in our case we're going to need both of them. Okay, include the file stream handlers to to use with our files. Okay, so that's gonna be our step number 2. So then what do we do? Well, we have file handlers, but we don't know where we're pointing to. So in this case, I need to find where I need to point to. So I'm gonna have infile, the infile dot open, and when we're opening something, we need to give a string, and that string gonna be, let's say, input. We're gonna call it input.text. Don't worry about it, we don't have it yet. We're gonna create it. So then we're gonna have out file.open. So that's gonna be our output file. So maybe we're gonna call that output.text. Okay. And that is also a string. So step number 3 was to open files. Now, because we're going to be reading in from the file, we don't really need to ask for a value anymore. Let me take these breaks off. Okay. So we can just comment this out, and later on we can put it back if we need it. But maybe we want to let the user know that we are reading something from a file. So maybe we do want to output something onto the screen. Reading from file. Please wait. Okay. So this is what's going out to the standard output. Now, because we have an input stream, and the input stream opened up a file, what we can do is actually not read from the standard output, but what we can do is use the infile, which is our ifstream data type, and read the value from the file. And as we're reading the value from the file, just like with CIN, the ifstream evaluates the data type of the variable where you're going to be storing the value, and that will determine how it will read the value from the file and what rule is going to be applied. So since this is an integer, when it opens up the file and tries to read from the file, it's going to be looking for a positive or negative value or negative sign. Then it will look for digits, and it will stop reading when it reads a white space or a non-digit character. Okay, it's the same way it works, just like it would if we would be using CIN. At that point, we can put the value out to the screen. But we did not ask a user to use this. So this is the value we read from the file. And then we display the value. Okay. So now what we can do is just because we read it and we display it to the screen, why not just also save it to a file? So in this case, instead of cout, you can actually use the out file and maybe print something out this was the value we read from the file. Just like if we would read it or print it to the screen. Okay, and then maybe we can send the value to that file as well. So step 3 was opening up the file. Step 4 was reading from file. Step 5 was writing to file. So at that point, nothing else left. Just we need to close the files. So in file dot close with the parentheses. There's no argument. There's no parameter list. Would be the better terminology. Okay. And we close both files, the in file and the out file, not closed. And that's where our program ends. So we can save the program at this point. Now, where are these files? Well, we don't really have them. So that means we need to find our file, which is in our project, and we need to put in a input file. So if we go to the Windows Explorer, then we can go to Computer Science, CUSC 1436, Hello File, right? Hello File, and we have our CPP file. At this point, we can right-click, New, Text Document, okay, and we call it input.text. So that just creates an empty file. So we're going to open up this file. We open the file, and let's say we can put in 2014 and save and close the file. So at this point, we can go back to our project. Now we should be able to see our file. So as soon as we read into the file, I'd like to stop the program at that point, and then I'm also going to stop after I close the files. So if everything works fine, then the value going to have a 2014 integer assigned to it after we read from the file. Okay, so here's our 2014. It worked fine. Continue on. Okay, and you can see that we actually have the 2014. It is displayed on the screen. So we need to make sure that it actually wrote the file as well. So let me just stop the program, go back to the file system. Here's our output.txt file, and it printed the text, and after the text it printed the actual integer value. Okay, so the only thing we had to have is the input file. The output file was created if it did not exist. Okay, so what happens if the file actually exists and we would like to still use that file? So let's say if we're just going to say this is the value. I'm going to take that breakpoint off, rerun the program, stop, Go back to the file system, look at the output. You can see that it did not append to the file, it overwritten the file. So be careful how you name your files, because you can overwrite and destroy the previous content. Okay, so the best way to make sure that you don't overwrite something is to pick a unique name that's not in that folder yet, and then that way you know you're not going to overwrite anything that's important. Okay, so what happens if we typing something wrong? Okay, let's say text, and we know that we do not have an input file called input.text, and I run this program. There is no error message, but the value is the garbage value because there was nothing to be read from the file itself. That file doesn't exist. So when I go to the output file, it actually outputs the garbage value into that file. So the program doesn't have any kind of a checking to make sure that it is not a garbage value that you are outputting to the file. So you need to, eventually we're going to learn how to put in some countermeasures for this and checking to make sure that we actually read something in. Also, what would happen if we would have the input file somewhere else? So let me just copy this input file, and I can go to maybe a file is in my temp directory. What I can do is I can say input, read the input from my C drive from the temp folder. Okay, so let's see what happens then. Run the program. Program runs, and as you can see, we still have a garbage value. So something did not work. Something doesn't work properly. So what we can do is we can think about what we learned in chapter 2, that the backslash has a special meaning. So if we'll see in a string, if we see \t, that actually means a tab to C++. So what we need to do is to escape the special meaning of that backslash with another backslash. So escape the first one, escape the second one. Now it means that c/temp/input.txt file, what I'd like to open up and read from. So let's see what happens. Stop the code. Let's run it again. And as you can see now, it actually read the 2014. So if you want to use the path, make sure that you use the double backslashes as the path or directory separator. Okay. So where's the output? The output is not in the same directory that we have right now. It is still gonna be in the same directory where our project is. So if we also would like to change where the output file is written to, we can also type in c:// let's say temp / output.txt. Now if I do that and I rerun the program, you can see that we did read 2014. If I go back to the temp directory, now I have the output file in that directory, and when I double click on it, now it has the contents because of our code. So that's pretty much all that we need to know. So step number 6 was create a file for input with the correct content, and in the proper folder that that you know exactly where it's supposed to be. Okay, so at this point we're hard coding the path, and later on we'll learn how to make that more dynamic. But at this point, the only thing that you need to remember is you do have to create the input file, put the proper content into that file, and then you put the input file in a place where C++ can actually locate it, and or your code can locate it and read the values from. Okay, so if you want to add another value, let's add another value here and make that a floating point value, and there's gonna be, let's say, price. Now what we can do is we can tell the input on the in file to go ahead and also read a value into price. So when we are printing it out, what we can do is we can print out the two values. So now we have price. Okay, but if I print them out right next to each other, we're not going to know what's going to be the integer and what's going to be the floating point value. So what I like to do is put a little space in between them. So I want to use output manipulation. So I need another library for that. So it's going to be called iomanip. Okay. What I need this for is to use the setW function. Okay. And what I'm going to do is I'm going to say setW, let's say 15. Okay. And maybe I want to print this out into 10 places. Okay. So we have the value and the price. So the value gonna be printed into 15 places, and then the price gonna be printed into 10 columns. So by default, they're gonna be pushed to the right side of those columns. So we did that. So we are reading an integer, and then we're gonna read a floating point value. So in order to do that, I need to change my input file, and I need to place in a floating point value, so the program can read first the integer and then the floating point value. And if you want to, you can also test that it actually works exactly the same way as the book describes, or as we learned it, that the input stream going to be parsing the plus and the negative signs as the unary operator. So it's really going to be look at it as signs and not as a addition or subtraction operators. So go ahead and save it. Come back to our program. Click on it. Run it. We go back to our folder to make sure that we have the proper spacing. Okay, so we have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Okay, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's our column. So here we had 16, right? But if you look at your code, there was a space after the colon. So it's really in a space of 15 columns. Right? So that's where the extra space comes from. Or sorry, right here. Okay. So what if I'd like to display this right against the left side? Then we can just use the keyword left. Okay. Rerun the code. And when we look at the output, now you can see that we just push the value to the left hand side of that column range. So that's how you use file for input and output with a little bit of output manipulation to control the nicer formatted output. Okay, but if you follow the steps and you follow the recipe, then you cannot go wrong, and it should be pretty simple and easy to implement for everybody. So I hope you enjoyed it, and hope that's going to be helpful for you to learn how to create a basic program on your own to read from file and output onto a file. Make sure that you do this exercise over and over again until you can pretty much do it without any kind of a help from this video or from any other sources. So I'll see you next time, and we'll talk about another concept. Bye.